Good morning, everyone. I am Jayalakshmi from Vailtech Multitech, Dr. Rangarajan, Dr. Shakuntala Engineering College, the Department Artificial Intelligence and Data Science. I am here to present the video lecture on the topic Predictive Analytics and EDA under the course Predictive Analytics. Before discussing about what is predictive analytics, we need to know about what is data analytics. Data analytics is a scientific process of examining raw data to draw conclusions and make informed decisions. It involves using various techniques to identify trends, patterns, and insights within the data, which can be used to solve problems, improve business strategies, and drive growth. Data collection is nothing but the gathering of raw data from various sources such as a database, spreadsheets, or external data providers. And about data cleaning, we'll be removing the errors, inconsistencies, and missing values from the data to ensure its quality and accuracy. Next is our data transformation. So it is nothing but converting the cleaned data into the format suitable for analysis, such as aggregating the data or creating new variables. Finally, is our data analytics. That is nothing but statistical, computational, and visualization techniques to extract insights and meaningful information from the data. In this slide, we will be discussing about why we need data analytics. We need the data analytics. Why? Because it is essential for the organizations to make informed, data-driven decisions for the business success. By leveraging data analytics, businesses we can make the valuable insights that inform the strategies, decisions, and drive the growth. Next is streamline processes and it reduces the cost and improve the efficiency. Next is to analyze the customer strengths, behaviors to develop targeted marketing strategies and improve customer satisfaction. Next, it may produce new opportunities, optimize pricing and develop data-driven business models. So next is our key benefits. What are the key benefits we need from the data analytics is that it provides actionable insights that inform business decisions. So next is our data analytics help organizations reduce cost by optimizing operations and streamlining processes. Next, we are going to discuss about the types of data analytics. So we have around 4 different types of data analytics. They are descriptive, diagnostic, predictive, and perspective. First is our descriptive. So under descriptive, it means what happened. So we need to give the answer for the question what happened by analyzing the historical data to understand past events, trends, and performance. So next is diagnostic analytics. So for this, we need to give answer for the question why did it happen by identifying the root cause of the problems or trends. So next is predictive analytics. So for this, we need to give answer for the question why is likely to happen by using statistical models or machine learning algorithms to forecast the future events or trends. So next is our perspective analytics. So under this type, we need to give answer for the question what should be done by providing recommendations for actions to be based on predictive analytics and optimization techniques. This is one diagrammatical representation for the types of analytics. The image represents a graph illustration of various types of analytics categorized by their level of difficulty and value. In this slide, we are going to discuss in detail about descriptive analytics. The type of analysis being described as descriptive analytics. It involves analyzing historical data to provide insights into past events, trends, and performance. So it helps us to answer the question like what happened or what is the current situation by summarizing and describing the data. So examples of the descriptive analytics include the calculating average sales, tracking website traffic, summarizing customer demographics. Descriptive analytics provides a foundation for further analysis such as diagnostic, predictive, and perspective analytics by providing a clear understanding of what has happened in the past. This slide defines the diagnostic analysis as a method that goes beyond the descriptive analysis to understand the underlying reasons for certain events or trends. It aims to identify the root cause of observed patterns. Diagnostic analysis build upon the insights gained from descriptive analytics. While the descriptive analytics provides a summary of what happened, diagnostic analysis reveals the deeper to explain why it happened. So that is the difference between the diagnostic and descriptive analytics, is that why exactly. So explaining why exactly the situation has happened now. So the practical example is providing to illustrate the application of diagnostic analysis in the context of a sales drop. Diagnostic analysis can be used to investigate various factors such as seasonality, promotional campaigns or competitors' activity to determine the cause of the decline. So overall, the image effectively communicates the value and methodology of the diagnostic analysis, making it a useful resource for understanding this analytical approach. The next type is our predictive analytics. So it utilizes the statistical models and machine learning techniques to forecast the future outcomes based on historical data. So this approach enables organizations to make informed decisions by anticipating the potential trends and outcomes. So the primary goal of predictive analytics is to answer the questions such as what is likely to happen or what are the potential trends. By doing so, it helps the business and organizations prepare for future challenges and opportunities. So this provides a several example of predictive analytics in action. So it can be used to identify the customers who are likely to stop using a product or service, allowing businesses to take the proactive measures to retain them. So by analyzing the historical data and trends, the predictive analytics can help businesses forecast demands of their products or services, enabling them to make improved decisions about production and inventory management. The next type is our perspective analytics. So this is a type of analytics that goes beyond the predictive future outcomes by recommending actions to influence those outcomes. So it is advanced analytics techniques that uses insights from various types of analytics to suggest optimal solution to a problem or opportunity. So it is the next step after descriptive diagnostic and the predictive analytics. So it works by leveraging the insights, understanding what has happened in the past and identifying the root cause of the past events. So forecasting what is likely to happen in the future. So by combining these insights, perspective analytics will provide recommendations on what actions on take to achieve a desired outcome. So for instance, if predictive analytics indicates a high risk of customer, so then the perspective analytics might recommend so target that particular customer, special promotions or discounts to retain that particular customer. So next, or we can tailored messages or interactions to build customers' loyalty. So by implementing these recommendations, so businesses can proactively work to retain the customer and reduce the costs. Predictive analytics is a process of using historical and current data to forecast future outcomes and trends by utilizing statistical and machine learning techniques to identify patterns and make predictions about what is likely to happen based on past information, allowing for proactive decision making. It leverages various data analysis methods like statistical modeling, machine learning algorithm, and data mining to extract insights from historical data. The primary goal is to predict future events, trends, or behaviors based on the patterns identified in the data. So it enables businesses to anticipate potential scenarios to make informed decisions in advance to mitigate risk and capitalize on opportunities. Next is why predictive analytics. So we need predictive analytics is used to forecast future outcomes based on historical data, enabling businesses to make more informed decisions, improve efficiency, and gain a competitive edge. It helps anticipate trends, optimize operations, personalize customer experience, and mitigate the risk. So essentially, it allows businesses to move beyond understanding the past to proactively shaping their future. So predictive analytics provides insights to potential future outcomes, allowing businesses to make more informed decisions across various functions. So for example, sales teams can use predictive models to estimate customer lifetime value, while operation teams can match staffing levels with demand. By leveraging data to determine potential outcomes, businesses can align their strategies with organizational goals. So, predictive models can optimize processes like inventory management, supply chain logistics, and resource allocation. So, this leads to cost savings, improved productivity, and better utilization of available resources. So, for instance, businesses can anticipate future trends and proactively allocate resources to areas with the highest potential for success. It helps businesses understand customer behavior, preferences, and needs, enabling them to deliver personalized product recommendations and targeted marketing campaigns. By understanding individual preferences, businesses can tailor their offerings and improve the overall customer experience. It can identify potential risk and vulnerability easily on, allowing businesses to take preventive measures. So, for example, financial institutions can use predictive models to identify potential transactions or credit risk. By anticipating potential problems, businesses can minimize losses and protect their assets. Organizations that leverage predictive analysis can stay ahead of the competition by proactively addressing opportunities and challenges. They can identify emerging trends, anticipate market shifts, and adapt their strategies accordingly. So, this allows them to gain a competitive advantage by being more responsive, innovative, and effective. The next slide is the key components of predictive analytics. So it relies on several key components to function effectively. These include data collection and preparation model, building and selection, validation and testing, deployment and monitoring. So these components work together to create predictive models that can be used to forecast future trends, behaviors, or outcomes. So next comes our data collection. So gathering relevant data from various sources, that is including historical data and real-time data. So next is cleaning, transforming, and preparing the data for analysis. This involves handling missing values, removing outliers, and ensuring data accuracy. So choosing the appropriate statistical or machine learning algorithm to build the predictive model. In common algorithms include regression analysis, decision trees, neural networks, and time series analysis. So using the prepared data to train the chosen algorithm and build the predictive model. So testing the accuracy and the effectiveness of the trained model using a separate data set that the model has not been above. So using metrics like accuracy, precision, recall, and assess the model's performance. So integrating the validated predictive model into business processes for several time decision making. So continuously monitoring the model's performance and retaining or updating it as needed to maintain accuracy over time. By effectively managing these components, organizers can leverage predictive analytics to gain valuable insights, anticipate future trends, and make more informed decisions. In this slide, we will discuss about how PA works. So it uses historical data, statistical modeling, and machine learning techniques to forecast future outcomes and behaviors. It identifies patterns and trends in data to predict what might happen next, helping businesses make informed decisions and optimize strategies. Predictive analytics relies to collecting relevant data from various sources, including historical records, customer interactions, and market trends. This data is then cleaned, transformed, and prepared for analysis, ensuring its accuracy and sustainability for modeling. Various statistical and machine learning models are employed to analyze the data and identify patterns. Common techniques include regression analysis, decision trees, and neural networks trained on historical data to learn relationship between variables and predict future outcomes. Once trained, the models are validated using test data to assess their accuracy and predictive power. The models are refined and optimized based on the validation results to improve their predictive capabilities. The refined predictive models are then applied to new, unseen data to generate predictions about future events. The results are monitored and evaluated to ensure their ongoing accuracy and effectiveness. In sense, predictive analytics works to identify patterns and relationships. Based on these patterns of new data that can be used to make better decisions and improve business outcomes. So predictive analytics finds applications in various industries, including retail, healthcare, finance, and marketing, helping business to improve computer experiences, optimize operations, and mitigate risk. It is a process of using data to forecast future outcomes. The process uses data analysis, machine learning, etc. The working process of PA also includes a data collection, preparation, model development, model training and validation, prediction, interpretation, and action. Next, we will discuss about how a problem is defined in predictive analytics. So, a problem is defined as a business question or objective that can be addressed by analyzing the historical data to predict future outcomes or behavior. So, essentially, it's about identifying a situation where past patterns can be used to forecast what might happen next, allowing for proactive decision making. So, it starts with a clear business question or objective. So this cloud be anything from forecasting sales to predictive customer to core of the predictive analysis problems, and this can be addressed by analyzing the data, especially historical data that can be reveal patterns and relationship. But to use that understanding to predict future events or behaviors, this prediction can then be used to inform decisions and strategies. So some common examples of predictive analysis, which includes predicting future sales based on the past sales data, seasonality, and other factors. So identifying customers who are likely to stop using a service or a product. So identifying transactions or actions, predicting the likelihood of certain events like loan defaults or insurance claims, etc. Predicting the demands of products or sales. So based upon the demands of a particular product. So next will be the predicting which employees can or at the risk of leaving the company. So as we'll define the predictive analysis problems includes a clear objective, that is what is the specific goal you're trying to achieve through predictive analysis. Next, we will discuss about how we will gather and organize data in predictive analytics. So in PA, gathering and organizing data are foundational steps involving collecting relevant information from various sources and preparing it for analysis. So this process includes data collection, data preparation, that is your cleaning and organization, and potential feature engineering to ensure the data is suitable for building and training predictive models. So in data collection, we will identify and gather data from diverse sources, about the various number of sources. Internal sources, we have transactional databases, so CRM systems, customer feedback, product usage, etc. So external sources, we have market research data, social media activity, web analytics, sensor data, and public data sets. So ensure the data is relevant to the specific prediction problem you are trying to solve. So next is our data preparation. So in this we will which involves removing errors, duplicates, and consistencies from the data. So we'll decide how to deal with the missing data points such as the imputation or removal. So convert that data into a suitable format for analysis, including scaling, normalizing, or creating new feature. So create new variables that might be relevant for the model based on existing data. So store and organize the data in a centralized repository for efficient access and analysis. So next will be our model selection and training. So in this we will be choosing the appropriate machine learning algorithm based on the type of the prediction problem and data characteristics. So use of the prepared data to train the chosen model, allowing it to learn patterns and relationship. So it also evaluates the model performance using a separate validation data to ensure the accuracy and reliability. Next, we will discuss about pre-processed data in predictive analytics. So raw data is only nominally useful by itself to prepare the data of the predictive analytics model. It should be cleaned to remove anomalies, missing data points, or extreme outliers, any of which might be useful in the result of output for measuring the errors. The next is develop predictive model. So in this, we will be discussing about how we will develop a model in predictive analytics. So it uses the historical data to develop models that forecast future outcomes. These models are built through a process of data collection, cleaning, future engineering, and algorithm selection, followed by the training, validation, and deployment. The key steps used in the business problem, selecting appropriate algorithms and ensuring data quality. In this slide, we will discuss about how to validate and deploy the results in PA, and it are the crucial steps to ensure the model's effectiveness and integrate its sites into the real-world applications. So rigorously evaluate the model's performance against the known outcomes or the test data types. So utilize the various metrics such as the accuracy, precision, recall, and qualify the model's performance. So the methods also includes the cross-validation, bootstrapping to assess the model's generalization, ability to robustness. Next, we will discuss about some common examples of predictive analytics. Some of them are marketing, finance, healthcare, manufacturing, and insurance. Next, we'll discuss about the common benefits of the predictive analytics. Some of the common benefits are improved decision making, risk mitigation, risk efficiency, and competitive advantage. Predictive analytics is the process of using data to forecast future outcomes by using the data and forecasting the outcomes. Some of the techniques used in predictive analytics are statistical methods, machine learning, text mining, sentiment analysis, and clustering. Here are some of the tools and technologies we will be using under predictive analytics. Amazon is one of the case study which comes under the predictive analytics, where we'll be using the product recommendations using collaborative filtering. Now we will discuss about what is EDA. It is nothing but exploratory data analytics. So it is the data analytics approach focused on investigating and summarizing the key characteristics of the data set, often using visual methods. The main objective of the EDA is it helps identify patterns, anomalies, and relationship within the data, which can inform further analysis and modeling the decision. Next is the importance of the EDA as it supports a better decision making with data-driven insights. The effective reduces the risk of the model failure. Next, we will discuss about different types of EDA. We have some 4 different types of EDA. They are univariate non-graphical, multivariate non-graphical, univariate graphical, and multivariate graphical EDA. The first type is univariate non-graphical EDA. So the main goal of this univariate non-graphical EDA is to know the underlying sample distribution of data and make the observations about the population. The next type is the multivariate non-graphical. So this is used to show the connection between 2 or more variables within the sort of either cross-tabulation. The next type is the univariate graphical. So in this type, this is used to describe and summarize the individual variables. Techniques include the histograms, blocks plots, and the frequency distribution. The next type is the multivariate graphical. So this involves more than 2 variables at a time. The tools like pair plots, heat maps, and PCA, that is your principal component analysis, are used. So it reveals deeper patterns and hidden relationship in the data. Next, the different types of missing data. There are 3 different types of missing data. They are MCAR, MAR, and MNAR. The first type of missing data are missing completely at random. So the current example for the MCAR is the customer accidentally skips a question in an online form due to distraction with no connection of the question's content or their previous answers. The next type is the missing at random. So the example for this MAR is the younger patients may be less likely to report certain symptoms than older patients, but the fact that the data is missing is independent of the symptoms themselves. The next type is the missing not at random. The example for this MNAR as in a survey on income, higher income respondents must be likely to disclose their income, making it more difficult to infer or predict their actual. SDG stands for Sustainable Development Goals. So they are the blueprint to achieve a better and more sustainable future for all. Here we have SDG goal number 2, that is zero hunger, which is related to predictive analytics. So it prevents food shortages, reduces food waste, and ensures better food security through predictive analytics. SDG goal number 3 is good health and well-being. So it saves the lives through early intervention, optimizes healthcare and resources, and lowers cost. SDG goal number 4 is quality education. Through predictive analytics, we can able to increase the retention, reduces inequalities in education, and enhances employability. SDG number 6 is clean water and sanitation. So through predictive analytics, we can ensure a safe, reliable water supply and efficient sanitation systems. SDG number 7 is affordable and clean energy. So through PA, we can able to support clean energy integration, reduces energy waste, and cuts cost. SDG number 8 is decent work and economic growth. So through PA, we can able to create sustainable job opportunities. That is nothing but a required growth of the job vacancies and prevents economic shocks and supports business resilience. SDG 9 is industry, innovation, and infrastructure. SDG number 11 is sustainable cities and communities. So through PA, we can able to improve the quality of the life. So enhance the disasters preparedness and builds a resilient cities. SDG number 12 is responsible consumption and production. So it encourages the efficient use of resources and reduces the environmental footprint. So this we can achieve through predictive analytics. SDG 13 is climate action. So through predictive analytics, we can able to improve the climate resilience and supports the global emission reductions targets. So these things we can able to achieve through the predictive analytics. So we can be able to predict the climate change impacts and models the carbon emissions and forecast the natural disasters for early warming systems. STG 14 is life below the water. So through predictive analytics, it can able to help the predicts ocean pollution and plastic accumulation zones. So models overfishing and marine biodiversity loss. So and forecast coral reef bleaching and sea level rise. So the impact of this life below water is that it protects the marine ecosystem and promotes sustainable fisheries. SDG 15 is life on land. Through predictive analytics, we can able to conserve the forest, wildlife, and promotes land restoration. Finally, we conclude that EDA and PA transform the data into actionable knowledge, while EDA answers what has happened and why, while the predictive analytics answer what is likely to happen next and how we can prepare for it.